Alright, today's lectures will be on chapter 5. The topic for today's lecture is IT infrastructure and emerging technologies. And as usual, there are few video cases that you can go through on your own or during the self-study mode in the second session of these lectures. The video cases are regarding ESPN.com, getting to extreme scale on the web, Salesforce.com, managing by smartphone, Axiom Strategy Advantage, IBM's virtual blade platform. And then there are two instructional video. Instructional video 1 is on Google and IBM produced cloud computing. Instructional video 2 on IBM Blue Cloud is ready to use computing. So I suggest, for your knowledge, when you have free time or on your own flexible time, please go through this video just for additional knowledge as required by this course. Again, I will not go through these case studies over here. Reason it will take longer time. So I really wish that you will go through this during your self-study mode. Okay, with that, let me share with you what are the lecture learning objective for this session. First, we're going to look into what is IT infrastructure and what are the stages and drivers of IT infrastructure evaluation, right? Next, we're going to discuss what are the components of IT infrastructure. We will continue our discussion with what are the current trends in computer hardware platforms, what are the current trends in computer software platform, and also we will take a look at what are the challenges of managing IT infrastructure and management solution. So these are some of the objectives. As usual, they have provided us one case study to be discussed at the second part of the lecture during the discussion, open discussion session. The problem is related to Toyota Motor Europe mix with the cloud. And the problem that this company is facing is providing a consistent maintenance service to millions of customers. So the problem is providing a consistent maintenance service to millions of customers by Toyota Motor Europe. So where I believe they want to make use of cloud computing as their IT infrastructure. So the solution provided or shared with us for this case study is cloud-based computing service that manages onboard computers in Toyota vehicles. So like we discussed earlier, they are planning to use cloud-based computing as part of the IT infrastructure to manage onboard computers in Toyota vehicles. Demonstrate IT role in reducing costs and improving security and customer service. So those are the two solutions provided for this case study. So I suggest you and your colleague or your group members please discuss this during your discussion sessions. And if you need to bring it up, we can discuss it together. Otherwise, think about it, how Toyota Motor are using these two solutions to overcome their problems. All right. So with that, let me start on IT infrastructure. So let's take a look at what is IT infrastructure. IT infrastructure means set of physical devices and software required to operate the enterprise. So this is a very high level, very general term or so-called definition on what is IT infrastructure. Set of physical devices and software. So there are two elements here, physical devices and software required to operate any business or enterprise. Set of firm-wide services. So if you are not really having any products, you might be providing services, then this second definition or meaning will be more useful to your case, to your business. Set of firm-wide services including computing platform providing computing services, telecommunication services, data management services, application software services, physical facilities management services, IT management, education, and other services. So it covers actually quite a huge area, quite a big areas. Reason, like what I used to say, IT is being used or is being adapted into more and more fields as we are moving on, moving forward. So you will see IT or MIS is everywhere. IT or the hardware and softwares, or in other words, IT infrastructure and related softwares are being used, being adapted, being installed, being implemented in more industries. The other so-called meaning or definition for IT infrastructure also is known as service platform perspective. So this is more to what we call view of value of investment. So you can use all or either one in order to explain on what is IT infrastructure. So connection between the firm, IT infrastructure and business capabilities are shown in this slide to have a good understanding on IT infrastructure and emerging technologies. So as a business, you might have business strategy, IT strategy, you might have all the IT assets. So all those are so-called input for the IT services and infrastructure for that particular business or entity in order to provide customer services, supplier services, enterprise services, business services, IT infrastructure services, and so on. So that is the connection, relationship between the firm, IT infrastructure, and business capabilities. Continue on IT infrastructure, just to give you some ideas. It's all started back in 1959 or even earlier than that. In fact, even earlier than that means even during World War II, some of the countries already start using MIS, MIS facilities or technology during the World War II itself. And there were some companies were developing IT technology or MIS technology for that purpose. But general purpose mainframe and mini computers basically started somewhere in 1959 until today. Just to give you some history, IBM first introduced their mainframe in 1958. Then the DEC means digital equipment computers, introduced mini computers, slightly smaller version than the mainframe in 1965. PC, or personal computers, or what we call desktop that we have today, started to appear somewhere in 1981 to today, to present. and IBM was again responsible introducing the very first PC in 1981, and then since then we see very much progress in PC world or in PC industry until what we have today: laptop, desktop, tablets, and so on. And then in 1983 to present, there was a new technology, what we call client server era, started or was introduced, where we see desktop clients uh, connected to servers, where we call that client server, and processing capabilities split between client and server. And then network was introduced like what we have today, and then slowly we started to have internet, other applications, and so on. So just to give you some feedback, general knowledge on how IT started from those days until what we have today. Continue on the evaluation of IT infrastructure. Enterprise computing started somewhere in 1992 until what we have today. Cloud and mobile computing started quite recently, somewhere in year 2000 to today. Cloud computing and mobile computing are hot topics where every company and every organizations are talking about it, going into it, implementing it as part of their IT infrastructure. So what is cloud computing? Just for your knowledge, computing power and software application supplied over the internet or other network. It could be not necessarily internet, it can be over virtual private network, it can be over any internet or any networking or network platform. It could be public, private, or remember we did talk about internet, intranet, and extranet. So this cloud and mobile computing can present in any one of these network platform. And as we know today, as I have just mentioned, it is the fastest growing form of computing today, the cloud computing and mobile computing. Just to give you some ideas, stages in IT infrastructure evaluation, from mainframe mini computers into PC and into client server that we have today. So that's how the changes or evaluation took place over many years until what we have today, what we call network, or international network, where it is connected either throughout the whole country or throughout the whole global or regional base. It again depends. Depends. Let me just take a look at the meeting, making sure no one is left out. Okay, there is a one chat. Let me check what is that. Okay, no new chat, so let me continue with my lectures. Please stop me if there is any question that you need to bring it up, we can discuss. Okay, with that, let me continue with the lectures. So in this slide, what you can see is how the enterprise computing are connected within the clients and servers, and how the internet is connected to the enterprise servers as well. And in the second part of the slide, what you can see is how the cloud and mobile computing are connected, are connected within the server and clients. And in cloud and mobile computing, as you all aware, is actually getting very smart and getting very what we call quite complicated, where you can see not only desktop and servers are there, but there are many other devices are also part of the network. So that is the reason why the term computers is actually not being used in some of the companies or in some of the documents anymore, but they prefer to call it as a devices. Reason there are more and more devices are being connected to the internet nowadays, or to the cloud computing or mobile computing, where you can see beside your mobile phone, beside your tablet, beside your desktop, there are other devices such as, for example, high density TV, or even fridge, even vacuum cleaner, or even other devices, other electronic devices like your car. Yeah, all are starting to get connected to the network, and you can have a communication with all these devices either synchronously or asynchronously. So this is actually what we call cloud and mobile computing architecture. All right, so if anyone has any question, please let me know. I can elaborate further. Otherwise, I will stick to what we see on the slide. The next slide, what it shares with us is what we call multi-tiered client or server network, or they call it N-tier, where on your left hand side is you, the client, connected to the internet, and then the internet infrastructure is connected to the web server. Web server is connected to the application server, and then you might have a sales, production, accounting, HR system, or any other systems in your organization that is connected to your own database, private database, proprietary database within the company. So this is how the linkage is between the client and the organization or any particular company. So this is a very high level, very general explanation or architecture. So again, it depends on your own business or enterprise. What are the departments you have? Who are the people in your organization? How the infrastructure is? What are the network type or network infrastructure that you have in your companies, and so on. It is much more complicated than that, but just to give you some ideas, in general, this is how all the clients and internet infrastructure and servers are connected. Moving on, let's discuss about technology drivers of infrastructure evaluation. In other words, what are the drivers behind this infrastructure changes or evaluation over the many years? One of the technology driver is, of course, we always refer to Moore's law and microprocessing power. As we know, the computers that we have today is much more powerful than we used to have many years ago or many months ago. So what the Moore's law is saying regarding the microprocessing power is computing power doubles every 18 months. Okay, so it's a bit difficult, it's a bit tedious to keep track of this, but this is what is happening in the real world, where you see the processing power, the chips power, the microprocessor power is doubling every 18 months. And this is the data from the microprocessor or chip manufacturer such as Intel, AMD, and so on. And there are many other smaller players. Of course, the biggest player is Intel and AMD. There are smaller players like Sony, Hitachi, and there are a few more. But the popular one that all of you are aware is, of course, Intel and AMD. Also, the other technology drivers behind this infrastructure is what we call nanotechnology. Yeah, nanotechnology, which is getting very popular nowadays, especially back a few years. Everyone is talking about nanotechnology, where the size of the transistors is actually shrinking further and further, becoming smaller and smaller, and it is already into nano size. Yeah, it is really small. comparable to size of a virus. So it's a comparable to size of virus. So that's how the size of the transistors or the chips is shrinking, but it is becoming more powerful, like what the Moore's law saying, that it doubles in every 18 months. The other technology driver besides the IT infrastructure is what we call law of mass digital storage. The amount of data being stored each year doubles. There are a lot of data over the internet that you can easily pull out and check. I'm not going to do that. Reason is not part of the slides, or I hope they might give you one or two slides where you are aware, as you are aware, amount of videos are being uploaded in a minute, especially to YouTube, amount of data being uploaded into Facebook, into Twitter, into Instagram over a minute. It runs into so huge, terabytes or petabytes or megabytes or gigabytes, all really huge in size. So at the same time, what is happening is, one, the volume is increasing. Like I've just uploaded all our videos, which is all giga in size, which takes quite some time to upload, but we have no choice, because it is a video file. The size is normally quite big, and you need to look for a platform where it accepts your upload, and then you can make it available for public or private to access to your video. And at the same time, what is happening is the cost of data is, or the cost of data storage is getting cheaper and cheaper, right? Okay, in the next slide, what you can see is basically from 2014, from 1970 until 2014, that is the data that they have provided to us. Processing power in terms of MIPS. MIPS means millions of instruction per second. Millions of instruction per second that the processor or the microchip is capable of processing in a second, versus number of transistors. So as you can see, the MIPS is increasing and the number of transistors also is increasing over the years. So the computer is becoming more powerful, can process more data, more information. At the same time, the number of transistors also is increasing to make it more powerful, as per the Moore's law. What you can see on the next slide is the falling cost of chips. As we all are aware, the price of the chips or microchips is getting cheaper and cheaper in terms of US dollars. Just for your knowledge, if you are interested, you can zoom into more details. There are current pricing is available on the internet, but this is quite outdated value. But the bottom line is the cost of chips are falling, getting cheaper and cheaper over the time, and definitely is getting more powerful, but the cost is getting cheaper and cheaper. An example of nanotubes that is based on nanotechnology, just for your knowledge, it is actually smaller than or thinner than a human hair. As it is written there, nanotubes are tiny tubes about 10,000 times thinner than a human hair. As we know, the human hair is already so tiny. We might have difficulties to look into it with our naked eyes, but just imagine the nanotube is 10,000 times thinner than a human hair, and this is the technology that they are using in a building or in making the microchips. So they can have millions of chips inside that microchips. For processing it, yeah, for processing it fast enough. That's the reason why they use the term MIPS, millions of instructions per second. What it says that the microchip is capable of processing millions of instructions within a second. Yeah, that's powerful is the computers that we have today. So we cannot just compare with PC or personal computers or laptop. Actually the terms is more to servers, yeah, to high-end servers, supercomputers, high-end servers, and so on. And like what I mentioned earlier, the cost of data storage is actually getting cheaper and cheaper. As you can see, this is quite a outdated data as well, but of course you can get the latest data from the internet today. For huge amount of data, the cost is really getting cheaper and cheaper. For example, cloud storage services provide 100 gigs of storage for just $1 USD, yeah, just for $1. And now a company like Google or Microsoft, they do provide you free data storage, a very limited free storage, and if you want more than that, you can just purchase it for a very cheap price. Yeah, the same goes to Amazon. So these are the companies, either Google, Microsoft, or Amazon. They all into this business, IT infrastructure. Besides selling hardware, they do sell software and storage for the users. There are some other technology drivers as well, as you can see in the slide. Please go through it yourself. I will not be able to go through every single technology drivers, but just for your information, please read through. Yeah. As I mentioned earlier, declining communication costs and the internet. As you all know, almost this number is quite outdated actually. An estimated 3 billion people worldwide have internet access. In fact, the number is continuously to increase. As we know, the world population is around 7 to 8 billions as of today. I'm very sure half of it or even more, yeah, you can get the latest numbers from the internet, will have access to the internet, to social medias or any internet platform or facilities. This slide basically some data about declining in internet communication costs. As we know, as we are aware, the communication cost as well is going down, going cheaper and cheaper as of today, not as expensive as those days. Let me cover another one or two slides before we take a short break as usual. We are still on the technology drivers of infrastructure evaluation. Let's look at some standards and network effects. First, I'm going to talk about technology standard. What it means by technology standard: specification that establish the compatibility of product and the ability to communicate in a network. So basically this is like a SOP, you know, specification available or established that is compatible among the products or services that is available to communicate in the network or on the network. Yeah. So there must be some what we call standard practices or steps or guidelines for your client, for the server, for any devices, yeah, for any devices to communicate over the network. So who set these technology standards? There are many professional bodies or organizations, mainly in US. They are responsible for coming out with such a standard. We might cover these standards in one of the chapter. Otherwise, just just for your information, you can find all these organization or people responsible for the standards over the internet. So their job, they are responsible basically for coming out with standard ways of communicating or using the internet. Otherwise there will be a lot of difficulties or non-standards in terms of practice or guidelines or instruction over the internet. So when this organization or those who are practicing standard, when they come out with a standard, and when everybody follows that, it's much more easier for everyone, meaning customers, users, everyone involved in the business, non-business, ordinary users, to use the social medias or the internet for communication purpose. All right, so that's the reason why the standards are very important, and maintaining the standard is even more important, so that everybody follows a single standard for the same purpose. Okay, so there are 7 main components in IT infrastructure. So before we go and discuss about what are the 7 main components in the IT infrastructure, which might take quite some time, let us take a short break, 10 minutes, 10 to 15 minutes break. Some of you have might just rush into